Hello, we're in the middle of creating interactive challenge sets. During this video, I'm going to show some examples of how we can get kids to construct, and then when they do construct something precisely, we can give them some feedback so that they're sure that they constructed it properly. So let's get started. I have two examples here, and then I'll give you some ideas on making one of yours. So this first one says try to move E, that's this point right here, in such a way that it creates a 30, 60, 90 special rectangle. Now, when you give this kind of a problem to students, they will at first move this in such a way that it says 30, 60, 90. And they'll go like this, and they'll try to make it so it's 30, 60 exactly. But even if they do get to that, even if they do get it so it's 60.00 and 30.00, you can always go here quickly and just say rounding and then go rounding and then go down to here or something, and then you find out exactly that if you give it to them when it's on automatic, there really is no way that they're going to be able to precisely or move it in the exact spot so that it is exactly 30, 60, 90. So they will wonder why the like when I said when you're successful the triangle will turn red. They will wonder why it hasn't turned red even though it may say 30 and 60 there. So we want to try to get them to, construct a 30, 60, 90 in a way that guarantees that it will be 30, 60, 90. So I'm going to show you the construction just to save time. We have our two angles here. So I'm just going to click on this, and this was the initial construction right there. So it's what I made first. I made perpendicular lines with this line and this line because I wanted the right angle, and then I found out the measure of this segment from here to here, that h, and I knew that the hypotenuse would be twice the measure of h. So I made a circle from here, and you go to this one right here where it says circle, center, and radius, and it asks you to give the radius, and so the radius that I gave was 2h. I just wrote in 2 and then h, and then this circle formed, which gave me an intersection right here. So I used the intersection tool there and there, and I have that point right there. Now that point is very important because if this E is exactly where D is, and it can't be approximate. If it's in the area, it won't count. But if it's in an exact area, then this will definitely be a 30, 60, 90 triangle. Well, so the way you make sure that it is that in terms of doing this problem, like if you're a student, you would construct just the same way that we did. You would say, okay, well, I want to make a line that's perpendicular to this line, like that, and then I know whatever this is, and you can figure out what that is by just knowing the name of it. So if I click on this and then know the name of it, just like I said before, so if you know the name, it looks like is that an iron? No, I'm not sure. But we'll figure that out. So then you just, like I said, you make the circle, center and radius, and you just say, we're going to say it's twice that. So 2, let's say I, and then okay. Oh, it was an I. So we'll say 2L. Right there. So that's exactly where it should be. I just doubled this. It turned out to be an L, and it gave me a circle that big. So now, as the student, I would just find the intersection, like here and right here, and I'd say, okay, well, I want this point to be where this point is. And again, I'm doing this as if I'm the student. So I would say, okay, well, what is the name of this point? I mean, you can double click on it to find what the name is. The name is G. So if I just say, okay, well, I'm going to reposition E so that the location is now G, and now you do that and it turns red. So there's a feedback that you needed, okay? So question is, if I just back up, well, I can just go into object properties, but the question is, why did this turn red? Like what was the work that made this turn red? And if you just click on this, you'll see, we'll go, like I'm clicking on this is the object property for this triangle, and you'll notice I just wanted D to equal E. And if you notice the original construction, if I can go back, I'm going to get rid of this. So the original construction, you should right there, this was D and this was E. So this had to be where this was. And I, as a teacher, I made all this to start. I hid like all this other stuff. So the student didn't see any of that stuff, but there was a point D, which was the location that they needed to get this to. So you'll notice point D moves with E. So it doesn't really matter how the student manipulates these blue points. The right answer is going to be still the intersection of a circle that's twice this with that perpendicular line. That's where it's going to be. So that will end up being the same thing. So even though the student, typed in a different different name, not D and E, they typed in that they wanted this to be G, it still worked. So that's one example of how you can get students to construct and then give them automatic feedback to let them know that they're correct. So that's one example. Here's another one. So for this one, you notice I have a quadrilateral, and the goal is try to create a rectangle, and the idea is that they'll be given the automatic feedback once they do it properly. So they may again go like this and say, look, I made my rectangle, but it's not precise, and you can prove that it's not precise by showing values if you want to. But the underlying construction looks like this, which means that I just made a line parallel to this base segment right there, dropped it off there, and then I made a line parallel to this one, dropped it off there, and then I had an intersection. I just would say that the E would have to be D. So again, when the student sees this, they're going to have to do that. So they say, quickly they would say, right there, let's parallel, and then parallel, and then intersect. And then we got to find out what that name is as a student. That is point F. So we'll say, we'll redefine E as a student, and we'll just say it has to be in that location. Has to be where F is. So you go like that, and then it turns red, and they know that it's correct. Again, let's go into the object properties, and it'll confirm for you again what we would suspect, because it's changed color. I go to click on this, and that's the polygon, and then we'll say advanced. Notice it says E equals D. So if I back up here, that was the condition that had to be met in order for it to turn red. That's the student construction part of it. I want to get rid of that. So now E would have to be D. And that D sits there even though the student doesn't know it's there. And when they construct a new point, the E, the D, and the other point end up on the same exact point because they've all been constructed the same way. So again, they like the automatic feedback. They respond to it. They wonder why this isn't precisely a rectangle, and you can explain that to them. I think it's a good way, sort of a math labby sort of problem for them to do. So that's just one type of thing you could do in an interactive challenge set on GeoGebra.